GTA Math, what's up? I'm kind of bootlegging it because I didn't get a great camera setup and I don't have my tripod, but I do want to go over this hyperbolic trigonometric proof. And essentially what we're trying to do is identify how these two different forms of writing the same thing equate to the same identity. So I always start with the more difficult side, but today I'm gonna do both so that way we can kind of see how they both equal each other. So I'm gonna write this one in orange. I'm gonna do this one in brown. So when we use different hyperbolic identities, the one for cosine is e to the x plus e to the negative x, all of that over 2, and then this is cosh x. And then when we have sinh, we do the same thing, but instead we change this positive to a negative. So we're gonna end up with e to the x minus e to the negative x, all over 2. We can combine this and make it one big fraction. Actually, I'll show the step. And this is just the healthier way to kind of keep track of what's going on when you do your work, because sometimes I get lost. Literally. And this right here is still our cosh. We're gonna combine like terms. And ironically, these cancel out. We got a plus e to the negative x minus e to the negative x. I'm gonna put a box over both of them. And since they both cancel out, I'm just gonna cancel the box. And then we have e to the x plus, 2e to the x over 2. And just to make life simple, we raise this to the nth power. I didn't forget about it. So everywhere I see an x, I'm gonna just put an n to it, because n represents any number that's real. So we really don't have to be perfect. And then I'm gonna do the same thing here. And then lastly, we're gonna leave this here. And this is e to the nx. And then I'm gonna take the sinh, and I'm gonna do that one over here. So we're gonna take this same identity, we already did that. That is goofy. I'm a goofy guy for that. Excuse me. We're gonna rewrite this. That's what I meant to say. It's getting late. I might make a few mistakes. It's been a long day, long week, but I'm not complaining. All right. So we're gonna take this and rewrite it, but we're gonna put n next to the x's. So very similar to what we did here. So I said I do this in brown. Let me hold my end of the bargain. So cosh, sinh, but we're gonna put the n's here. So we're gonna have e, x, we got the n, then we got plus, e, negative, n, x, plus e to the x. Don't forget about that n, baby. And then we got minus e to the negative n. Then we have our x. All of this over 2. Kind of went over it here. There's no point in reiterating myself if we know what to do. And ironically, we have the same layout. We raised everything to the nth power in this part of the problem. And then over here, we raise everything to the n. And the same level of cancellation takes place, right? So I'm going to make these circles this time. E to the nx, e to the nx. And then I'm going to make this a w, because you're about to be like, where did they go? And I'm going to be like, out of here. And then now we're left with e to the nx. And we have two of them. So I'll write this 2 in orange. All of this over 2, right? So these proofs are relatively equivalent, and I'm gonna clean the work up so it don't look crazy. But as you see, we have 2e to the nx here, 2e to the nx here. So we really have 2e to the nx equals 2e to the nx. This over 2, this over 2. And ironically, the 2's cancel out. So we're really just left with e to the nx equals e to the nx. And this is how we prove the hyperbolic function of cosh x plus sinh x raised to whatever degree of a polynomial is going to be equivalent to the same statement here. So what we're saying in more regular terms, I don't want to be offensive, because sometimes that happens when you say things that are not necessarily making sense. We took the regular cosh function, we rewrote it, and then we used the actual hyperbolic e terms, and we put them in, but all we did was added an n, which could have been any number, but we used the variable. It's Calc 2, so things make sense this way, at this level, but it is cleaner. And then we did the same thing here. So all we did was added an artificial number in really a variable, and we just said, hey, look, as long as it's cosh in relation to an independent variable, whatever number we put in front of it, a constant, it's going to give us the same statement if we do the same thing to both sides. GTA, I appreciate you. Let's continue to learn, love, grow together. Good luck.